Hi, this is Leo. In this lesson, we are going to learn how to do sheet metal design in ZW3D. And here is all the content we will cover in this lesson. First is the sheet metal design workflow, and then is the sheet metal attribute. And the next is how to create and edit sheet metal, and then how to do the corner treatment. After that is the forming tools and the bending tools. Then it will be the 2D sheet for sheet metal. And then there will be a case study. And the last is how to convert solid to sheet metal. Okay, now let's begin the first chapter, the design workflow. In ZW3D, the recommended workflow is very concise. First, create the sheet metal part, and then set the attribute, and then create the base. And the next is design the features, like the flanges, forming features, and etc. And then it's flatten, and then lead to the 2D drawing. Okay, so in the following chapters, we are going to go through all the steps, one by one. First, let's talk about the sheet metal attribute. As we know, for a single sheet metal project, the attribute like thickness, bend radius, key factor tends to be the same. So we can predefine the global attribute to avoid mistake and accelerate the design work. Let's check more details. Alright, foremost, let's see how to call out the attribute tab in the History Manager. As you already know, we can create a sheet metal part by two methods. First method is select the sheet metal as the subtype when you create a part. So in this case, the attribute tab will be available for you once you click OK button. And the next method is suitable for the cases where you just created a common part instead of a sheet metal part. So in this case, you need to extrude a base here or base flange to call out the attribute tab. Okay, now let's see what's inside the global attribute tab. The attribute tab inside can be divided. The attribute inside can be divided into two parts: standard and corner attribute. For standard attribute, it's related to some common attributes such as thickness, bend radius, flange position, length, key factor, relief, and etc. As for the corner attribute, it will decide whether to close the corners between the flanges and how. Alright, maybe some of the concept is not so easy to understand if you don't have much experience on sheet metal design, such as the key factor, relief, and the corner attribute settings. So in the next few pages, I will explain in detail. Okay, the first one is key factor. As you know, after the design finished, we need to unfold the sheet metal. But how do we calculate the total length after unfolding? Okay, as we know, when you do the unfold process, the inner material of the bend will be stretched, and the outer material, on the other hand, it will be compressed, right? So there must be a neutral section where the material neither be stretched nor compressed. So the unfolded length of the bend equals to its length. In this case, the length after unfolding can be simply calculated by the sum of the straight length and the length of the neutral section, which is the arc. But how do we find the neutral section? This is where we need to introduce the concept of key factor. It stands for the ratio of the neutral thickness to total thickness, and it's affected by multi-factors like material, thickness, bend radius, and bend angle. And from this, we can extend more concepts like bend allowance and bend deduction. For bend allowance, it means the length to be added after bending, which is here. As for the bend deduction, on the contrary, it means the length to be deducted after bending, which is here. So for the bend allowance, the unfolding length will be A plus B plus BA. But for the bend deduction, the unfolding length will be A plus B and minus BD. And for those settings, whether it's key factor, bend allowance, or bend deduction, we can predefine the values or formula by tables, and they are completely available for customization. The process is also easy. Just open the template table in the installation folder, then modify the values like unit, material, thickness, radius, and the corresponding values. Later I will show you in the software. And the next attribute is relief. A proper relief can protect the sheet metal from being torn. And the ZW3D offers two types of the relief shape, rectangle and oblong. And there are some dimension settings under each type. And another one is the corner attribute. Use this option to close the corner so that the edge of the flanges meet or have a narrow gap. And another option is whether to meter the corner. When you uncheck it, it will use straight line to form the outline of the cutter, which is going to cut the corner on the unfold pattern. And this is good for cutter manufacturing. Otherwise, it will use the curves to form the outline of the cutter, which is trying to meet the defined gap around the corner. But it's not that easy to manufacture as the first one does. And to combine the meter, corner, and relief types, there can be 10 different results, as shown in this table. Alright, now let's move over to the software to see more details. Okay, first of all, let me create a new sheet metal part. Okay, and now we can edit the sheet metal attribute. We double click on it, and there will be a tab. And here you can see we have standard attribute and the corner attribute. So let's say standard attribute first. For the global value, which means the thickness and the bend radius of the sheet metal. And also we have flange parameters. For the position, we have 5 different position options, like material inside and material outside. And also we have a natural and the offset value based on the natural. For example, we can give it an offset value like 5. And the last one is a virtual sharp. And later I will show you those different positions in the full flange creation. And for length type, first one is we measure the straight height. And the second one is we measure the outer height. And the next one is inner height. And last one is extrapolated height. And for the height, we can also customize it. And for the key factor, I already showed you the meaning of the key factor. Here you can see we have custom. We can define the value directly. And for the from material, it will give you a key factor based on the material you selected. For example, here we can select another material. Let's see, maybe a steel 2. Yeah, this material. And here you can see it will change. And actually, we have a table to define the material and the key factor. We can open it. And here you can see you can change the material and also the corresponding key factors in this table. Okay, it's in the installation path. Okay. And also we can see more types. Next one is bend table. We can also open it to see more details. Bend table, open it. And here you can see the key factor will be defined based on the unit, material, and also the angle. And also this table is also customizable. For example, for the radius and the thickness both equals 1, we can set the key factor 0.33. Okay. And for the material and the angle, we can also customize it. For example, material, we can change it to steel and steel tool. Okay. And also we can add more material here. For example, we'll add a steel, mild steel here. You can add it. Okay, and if you want to make more material, you can just copy it and paste it below. And then you can set the material and the corresponding key factor. For example, here we use the aluminum material. Aluminum. Okay. And then you can set the key factors based on the material. For example, we can set it 0.35. Okay. And also you can set different key factors for different radius and thickness. Okay, after that, we just save it. And before that, you can see actually there are more tips to customize this table. You can check it for details. Okay, we just save it. Okay. And let's say there are more key factor types. For example, the bend allowance table and the bend deduction table. Let's check the bend allowance table first. And here you can see, for the example, it's in the inch unit, and the material is copper and the brass. Okay, and you can find the bend allowance value in this table, and also it's customizable. It's the same method. You can just copy it and paste below, or you can just change some settings from the template. It's also available. Okay, for example, in this case, we can copy it and make the brass material another table, and you can change the bend allowance value directly in the table. It's the same way. Okay, you can save it. Okay, and for the bend deduction, it's the similar thing. We can just open it and check. It's very similar to the bend allowance table. You can do the same thing to it. Okay. And let's minimize this window and see more details. And also we have a bend allowance formula table. This one is interesting. We can just calculate the bend allowance based on a set of formula. You can see it here. It's the formula, and for different materials and different angles, you can also set it here. Okay, there are some subscriptions. Okay, close it. Okay, besides that, we can also offer more options. For example, we can input the bend deduction directly. And also, the bend allowance we can also input directly. Okay. And for the relief, we have two relief types, rectangle and oblong. Okay, for example, rectangle, we can set more parameters like the width, like the depth. For oblong, it's also the same. We can set different values here. And this is all about the standard attribute. Next, let's see the corner attribute. The first one is whether to close the corner. You can check it. And we need to decide whether to meter the corner. About the difference, I will show you later. Okay, and also we can set the relief for the corner. We have 4 types of relief. Okay, and also the gap, you can predefine it. Okay. And this the flat tolerance. We can just leave it by default. Okay. And also we can reuse the attribute settings. For example, we can import from outside or export our settings to a template. For example, we give it a name, sheet metal attribute template. Okay. You can save it. Okay. And there are more settings. First one is add the sheet metal flat automatically. You can check it. Then it will add the flat solid and the flat pattern automatically. The last option is update all part config. That means the modeling history will be region once you click on accept button. Okay, that's all about the sheet metal attribute. Thank you.